For this example, we have two premises. The first one, I study for 5 hours or I fail. The second premise, I did not study for 5 hours. So I'm going to write here. So this is the premise number 1. And the second is the premise number 2. Therefore, I fail. I fail. Therefore, I fail, which is the conclusion. We're going to identify the simple statements in the symbolic form. So let P represent I study for 5 hours. Statement Q represent I fail. Okay, and then we're gonna rewrite the arguments here in terms of symbolic form. For premise number 1, we see the connective or there. The first sentence, I study for 5 hours, or the next followed by I fail. Therefore, premise number 1 in the symbolic form gonna be P or Q. Premise 2, I did not study for 5 hours, which is negation of the statement P. Draw the line, therefore, dot, 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 that's a symbolic form for the therefore. The conclusion, I fail, which is the statement Q. Now we write it in a symbolic form. Next, we're gonna write this one, I write it down here. This is symbolic form. And then next, we're gonna write it as the compound statement. The compound statement, the premise number 1, premise number 2, connect with the and together in the brackets. Then conclusion Q. So now we have the compound statement to represent this argument. We make a list. How do we construct the truth table? We're gonna need the column for P, for Q, for the premise number 1, which is P or Q, for the premise number 2, which is not P, and then the two premises with the connective and, the P or Q, and not P, and then the last one, which is the argument. So we need 1, 2, 3, 4, 5, 6. We need 6 columns. I'm going to add another slide. From the compound statement, P or Q, and not P, then Q. So the table that has, we're gonna need 1, 2, 3, 4, 5, 6 columns. And the number of the row gonna be 5 rows. As we make a list, we need the column for P, for Q, for P or Q, for not P, and the two premises in one column with the connective and the last column is the argument or the compound statement for the argument. For the P and Q, by default, it's going to be true, true, false, false, true, false, true, false. the or, put the note again. For the or, only false or false will give you false. Otherwise, you're gonna get true. For our case, we have true or true. Gonna be true. True or true. True or false. Gonna be true. False or true. Gonna be true. The last case gonna give you false. Next column is negation of the P. Opposite of the P, which is false, false, true, true. And then the column next to this gonna connect these two that I circle in yellow highlighter here with the connective and. For the and, only when both of them true, the answer gonna be true. Otherwise, gonna be false. So we connect these two with the and. And the answer for this gonna be, they don't look like both are true, gonna be false. This gonna be false, and this gonna be true, and this gonna be false. And the last one, whatever we just got, which is the result from connect all premises together. We're gonna use this column with the column for the Q. I'm gonna make a partition a little bit over here with the Q column. Copy the truth value for the Q, which is true, false, true, false. Connect with the if then, or the conditional statement. And put a note here for the if then or the conditional statement. Antecedent true, the consequent false, gonna give you false. Otherwise, gonna be true. So the result that we are looking for, false then true, gonna be true. False then false, gonna be true. True then true, gonna be true. False then false, gonna be true. Looks like we get all cases come out to be true. Or we call this is a tautology. If it is a tautology, therefore, we can say this argument is valid.